So we're looking at applications of the normal distribution. Standardizing a normal random variable. So we're going back to our z-scores. I don't know if you remember, but we talked about z-scores before. We really only talked about calculating them. But now we're going to talk about the application of them. Where in your z-score, you have z is equal to x minus mu over theta, not theta, sigma, excuse me, over sigma. And that basically means, this right here, your data value minus the mean divided by the standard deviation. So that's what we're going to hold true to. No matter what symbols you use to calculate your z-score, it's always going to be your data value minus the mean divided by the standard deviation. All right. All right, so to do this application, we need the chart on pages A11 and A12 in the appendix. So whenever I reference the chart, that's what we're talking about. I believe I have this chart somewhere. I should anyway. Yeah, I do. No, I don't like that one. Anyway, okay. I'll just pull it up in my math lab before we leave so I can show it to you guys. All right. So our z-scores, remember, they are always rounded to 2 decimal places. All right. So the way we'll read our chart is that, let me see, is everybody done with this purple? Scroll all the way up. Do it like this. All right, so the way we'll read our chart is that we'll take that, let's say if we had 1.23, we'll take the 1.2, and that will be on this left column right here. And then the 3 would be on this top row. All right, so once again, 1.23, that 1.2 will be on this column over here, and this 0.3 would be on this top row. And so you go to the chart and see where they meet at, and that's the value you'll pull from the chart. All right, so let me go pull up the actual chart while you guys are looking at that. All right, so all right, so this is the first side. Notice all of our values over here are negative, and there's also so I think this is A11. But you know, let's say if I had that positive 1.2, then I wouldn't use this one because this has my negatives value. So I'll go to my positive one. So let me share the positive one. All right, let me stop the share, man. All right, so now see my column over here now is positive. So I would look for 1.2. Let's see if I can magnify it. Oh, it won't let me. Okay. So we have 1.2 right here and 0.03 up here. And where they meet is the value I'm going to pull from the chart. And that's 0.8907. All right. So before we talk about what that value means, questions on what I did. So once again, the chart value or the z-score that I have is 1.23. So 1.2 is right here. And then the 3 is right here. Then I go to where they meet in the chart to get my chart value. All right. Let's go back to the notes. So the chart value will always give, and I didn't emphasize that when you look at your picture. Let me go back here. Notice you have this right here that lets you know that this chart will always give you what's to the left of your data value or what's less than your data value. So if you were to Google Z-score charts, all charts aren't the same. They give you the same values if you know how to use them, but they don't give you the same numbers initially because it depends on how they're set up. So this one is set up to always give you what's to the left of your Z-score value. All right. So as I mentioned, the chart will always give you, or will always represent what is to the left of the data value, or in other words, what's less than. If I want to find out what is to the right of the data value or greater than, I subtract the chart value from 1. Remember we talked about that last class. You know, everything under the curve is equal to 1. So if I want to know what's to the right of or what's greater than my data value, I will subtract the chart value from 1. All right, and like I said, we'll talk about what that means right now when we look at this word problem. Questions on the chart before we go and use values. Talk about what they mean. All right. A pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and standard deviation 3.17 inches. Determine the proportion of the 3-year-old females that have a height less than 35 inches. So I'll give you guys a chance to write that down for those who are writing it down. All right, so we write down our givens. That's what we have right here. Our mean is 38.72. Standard deviation is 3.17. And our data value that we are, or the data value in question is 35 inches. All right, find your z-score. 35 minus 38.72 divided by 3.17. So it's your data value minus the mean divided by the standard deviation. And that gives us negative 1.17. So we got negative 1.1 that'll be on this left side. 0.7 will be up top. 0.07 will be up top. Oh, didn't even do that. There you go. So I just wanted to show you that. So he talked about negative 1.1 is right here. 0.07 is right here. So there it is, 0.1210. All right. So once again, the chart always gives less than. So we will use the chart value because we wanted to find out less than. So there are going to be three scenarios that we're going to deal with. It's going to be less than, greater than, or between. So once again, if the chart, if they asking for less than in the chart, then you take the chart value that they give you. All right. So the answer is the proportion of the pediatrician's 3-year-old females who are less than 35 inches tall is 0.1210. Or another way of saying that is 12%, 12.1%. You know, if you were to convert that to a percentage, it's 12.1%. Questions, questions, questions. Once again, the chart always give you less than. All right. Using the previous problem, find the probability that a randomly selected 3-year-old girl is taller than 37 inches. So the key phrase here is taller than. So there'll always be a key phrase that will let you know whether you're doing less than, greater than, or between. Taller than is another way of saying greater than. So we have our mean, standard deviation, and our data value, which is 37. So using that, that'll give us negative 0.54. So that'll be negative 0.5 on this left column, and that 0.04 will be on the top row. Where they meet will give you 0.2946. All right, so we're looking at what we have in the red over here. The chart always gives less than. So to find greater than, subtract the chart value from 1. Would that look better? All right, so you do 1 minus 0.2946, and this would be our answer, 0.7054. All right, any questions? Any questions? Any questions? All right, so using the previous information, find the probability of randomly selecting a 3-year-old girl that is between 35 and 40 inches tall, inclusive. So once again, there are 3 scenarios that we're going to come across when it comes to these Z-scores and the Z-score application. You have less than, greater than, and then between. All right, so our third scenario is between, and we have 2 values that we need to find Z-scores on. Standard deviation and mean are the same. Data value, our first data value is 35, second data value is 40. So in the purple, I found the first data value, 35 minus, first Z-score. So that's 35 minus 38.72 divided by 3.17. That gives us negative 1.17. And then 40 minus 38.72 divided by 3.17 gives us 0.40. Any questions? Any questions? All right, so go to the chart. Get our chart values. 0.121 for that first Z-score. 0.6554 for that second Z-score. Okay, scroll up. All right. So to find out what is between the data values, you're going to have to subtract them from each other. And this is the reason why. Just giving you the diagram right here. You know, you always get what is less than in both cases. So the chart will give you what's less than Z1 and also what's less than Z2. So what I'm going to do is take this first part away from the second part, and that'll give me what's in between them two. So just giving you a visual as to why we're doing it. So 0.6554 minus 0.121 is going to be 0.5344. Any questions? Any questions? All right, so we have, like I mentioned, those three scenarios. We have less than, greater than, and between, and there will be phrases that will let you know they're not going to always say less than, not going to always say greater than, like I showed you in the previous examples. There will be some, like in the greater than, we said taller instead of less than. So anything that reference less than, talking about shorter, colder, below, under, something of that nature means you're talking about less than. Greater than, taller, hotter, above, and then between is pretty much. I can't think of another word for between. So as far as I know, between will be it. But notice the action that you will take. If we're talking about less than, the chart value is the answer. Greater than, you're going to subtract the chart value from 1. And then if you're talking about between, you're going to subtract the chart values from each other. Notice we're not subtracting z-scores. We're not saying we're subtracting z-scores. You're not going to take the z-scores subtracted from 1. We're talking about the chart values. So you go to you calculate your z-score, go to the chart, use your z-scores to get a chart value. That chart value is what you would be, either that'll be your answer, subtracted from 1, or subtract from each other. So we're not doing that with the z-scores. Questions? Any questions? Hold on. Thought I had this pulled up. So that is it for 7.2. You only have those 3 scenarios that you have to make sure you okay with. So assignment 3, I want you guys to do. There you go. It's 5, 7, 9, 11, 37, and 39. So it'll be in your best interest to try those problems out. See if you get stuck, see if you have any issues with it. And those is right here on this left panel in my math lab. And because that's what I want to do next class is address any questions you guys may have had with trying these z-scores out and applying these processes. Don't forget, chapter 7 is just 7.1 and 7.2. And so be looking to review first before we do anything else. So make sure you try out these 5 problems. If you do these 5 problems, then you're pretty much good with chapter 7, because that's all chapter 7 is really emphasizing, the application and the process of these Z-scores. All right. Questions on that? And like I say, you don't necessarily have to write those down right now. They're right here in assignment 3 in my math lab. All right. Questions on anything? Is everybody okay?
No, I had to talk to you about my test.
Okay. All right. So anybody else before we close out as far as lecture is concerned? Is everybody good? All right. So that's it for today. Like I said, that's it for chapter 7. It's only 2 sections in chapter 7. So we'll look to review next class, see if you guys have any questions on anything. I won't know if you have any questions unless you bring it to the table. If not, then we'll go ahead and jump into 8.1. So you guys have a great weekend. Be safe, and I will see you on next class.